This is question 9. The statement says that the bracelet below, so this bracelet is beaded with or is beaded by using 10 plastic spheres. So it consists of beads, as you can see there. There's 10 plastic spheres, so they are beads which are spherical, and there are 10 of them. And then we also have 10 beads which are cylindrical. So let's say this is a cylinder, so we also have 10 beads that are of cylinder in shape. So when completed, the bracelet will be painted. Ignore the holes in the spheres and cylinders. The following formulae are given. So this is the volume of the cylinder, and this is the volume of the spherical. This is a surface area of the spherical, and then this is the surface area of a cylinder, right? So the following essential properties of the beads are, so the radius is r of the sphere and the cylinder are the same. So the radius of the sphere and the radius of the cylinder are equal. The height of each cylinder is h, so height is h, so the height of the cylinder is h. 9.1, if the volume of cylinder is 6 centimeters cubed, write down h in terms of r. So we're talking of the cylinder, and we are told that the volume is equals to 6 centimeters cubed, the volume of a cylinder. But we know the formula for a volume of a cylinder, it's pi r squared h, and we are told that it's 6, so you need to write in terms of r. So it's going to be pi r squared h. You divide by pi r squared, divide by pi r squared. So our h is equal to 6 divided by pi r squared. So this is the height of the cylinder with respect to r. 9.2, we are told that show that the total surface area of all painted surfaces of the bracelet is equal to this expression here. So for us to show the required question, we need to add the entire surface area. So the surface area of a cylinder, we must add it to the surface area of a sphere. So the surface area of a sphere, we need to add it to the surface area of a cylinder. So what you're going to do is we're going to the surface area of a cylinder, it's 2 pi r squared plus 2 pi r h, plus the surface area of a sphere, which is 4 pi r squared, right? So we're going to add like terms. So this is a like term of this one, so we'll add them together. So it's going to be 6 pi r squared plus 2 pi r h. Remember that h is given as 6 divided by pi r squared. This is an expression we found in 9.1. So we're going to substitute that expression. So it's going to be the surface area, the total surface area, being equals to, so you're going to write this expression, but instead of writing h here, we'll substitute it with this h here. So it's going to be 6 pi r squared plus 2 pi r. So where there's h, we'll put 6 over pi r squared, right? And then what we're going to get is 6 pi r squared plus, so the 6 multiplied by 2, it's going to give us 12 pi r, and then divide by pi r squared. So this pi goes away, r goes away. We have 6 pi r squared plus 12 divided by r, because this is r squared and this is r. And this is the total expression, but we need to remember that there's 10. So we should remember that there's 10 beads which are of cylinder shape, and there's 10 beads which are spherical. So we need to multiply the surface area by 10. So meaning the surface area is equal to 6 pi r squared plus 12 over r. You multiply everything by 10. Then what you're gonna get is the 6 multiplied by this part here. It's going to be 60 pi r squared plus the 10 multiplied by the 12 here. It's going to be 120 over r. So this is the expression of the total surface area. Now I'm going to do 9.3. 9.3 says that determine the value of r so that the least amount of paint will be used. So to determine this value of r so that the least amount of paint is used, we need to use our surface area, our total surface area, which is equal to 60 pi r squared plus 120 over r. So to find the value of r such that least paint is used, we need to find the derivative of this expression here. So S of r is equals to 60 pi r squared plus, we take the r to the top, it's going to be 120 r to the power minus 1, and to find the derivative of this expression, the 2 goes down, so it's going to be 2 times 60 pi r to the power of 2 minus 1. The minus 1 goes down, we have minus 120 r to the power minus 2. So our derivative is going to give us 120 pi r to the power of 1 minus 120 r to the power of, because there's minus 1 here, remember that it was minus 1, sorry, it's minus 2, because here it was minus 1 gives us minus 2, so it's going to be to the power of minus 2. Right, so this is the derivative of r, but it's derivative of the expression, rather, the surface area, the derivative, and then we're going to equate the derivative to 0 because we are looking for r. So 0 is equals to 120 pi r minus 120 r to the power minus 2. So you're going to divide by 120 r, divide by 120 r, divide by 120 r. So what's going to happen is you have 0 here is equals to pi minus r to the power of, because this is r to the power of 1, if you take it up, it's going to be r to the power of minus 1. So you're going to have r to the power of minus 3, because it's same base, they add exponents. So this goes away, and then you are left with this. So r to the power of minus 3 is equals to pi. And to remove this to the power of minus 3, we have to multiply by negative 1 over 3, multiply by negative 1 over 3. So our r is equals to pi to the power of negative 1 over 3, which if you write it properly, it's going to be r is equals to 1 over pi to the power of 1 over 3, which approximates to 0.68 centimeters. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.